Hello.
Hello, Dr. Smerdon. How are you?
Good. How are you doing, Jesse?
Good, good. Thanks so much for chatting with us today.
Of course, it's my pleasure.
We're really excited to hear about what you're doing. And yeah, my name is obviously Jesse Daly, and I want to just introduce you, I guess, through Zoom to Dennis Paolaha, who is also here. And Dennis will be kind of the one that will be asking some questions and taking the lead, but I'm happy to make the introduction.
Nice to meet you, Dennis.
Good, nice to meet you. I saw a couple of your videos. I think you look different.
Yeah, my hair's probably a little longer.
Yeah,
The pandemic has affected us all.
I know it has. I know it affected me. Yeah, this is interesting. I know it started with you being quoted in an article about Hurricane Ida. But when the emails went back and forth, you kind of made it clear that that's not your primary focus or not your only focus. So that sounded good. And I guess I made some notes rather than questions. But the reason I thought it might be interesting is the media and people talk about climate models, but it's always sort of secondhand. It's, we heard about the models doing this, models doing that, but you're at the Lamont-Doherty Earth Observatory, and from what I can tell, you're the guys making the models, or at least some of them. I'm not sure if anybody has organized or has such a large facility with as many people as you do. I was in it years ago. It was small. Nobody had anything close to what you guys are doing now. But could you just talk kind of quickly, sort of like in a layman's version of what does somebody do to put a climate model together?
Well, actually, we don't build climate models at Lamont. So that's not. So there is a center affiliated with Columbia and Lamont, the NASA GISS laboratory, which does build and maintain the NASA model. So the GISS Model E is one of the major modeling centers in the United States and globally. Just for some perspective on these models, maintaining them, running them, improving them is a massive effort. So actually doing that work requires a large group of people in and of itself, just maintaining, updating, running, managing the output, and so on. And so there are really three primary centers, although four now with DOE, but there's four main climate modeling centers in the US. There's the NASA GISS Lab, there's the National Center for Atmospheric Research in Boulder, Colorado. There is now the DOE facility as they build up their own model. And there's the National Oceanographic and Atmospheric Administration, or NOAA, lab that maintains the geophysical fluid dynamics model, or the GFDL model. So there's, within the United States, there's four major modeling centers. And it's useful, I think, just to give people an idea of how big this effort is. That's within the United States, but worldwide, there's another, collectively, there's 30 or 40 modeling centers worldwide who are developing models, running those models, making the output from those models publicly available. Some of it's done under decided protocols that's released as part of the IPCC, or the other Intergovernmental Panel on Climate Change reports that come out. So there's a massive effort to build these models, run these models, create output from these models under specific experimental configurations, and then compare the output of those models. One of the things that we do at Lamont is we use a lot of that model output to evaluate how the models perform in different settings. So we do run atmospheric models at Lamont, and there is some work done on that. But one of the areas where we, and by we I mean many of the climate scientists working across Lamont, really do a lot of work, is to take the public database of simulations out of the models worldwide and evaluate them in different scenarios and settings. And that's a tremendous amount of data. So those public, so for instance, the model database that was released as part of assessment report 6 of the IPCC is several petabytes in size. If that doesn't mean anything to you or your listeners, it's a boatload of data comparable to other I think it's second only to the CERN database from the particle collider in Switzerland. But that's a database that's approaching Google, Amazon sizes in terms of comparisons.
Okay, because some of the issues that are, I guess, they come up now in sort of in the public arena, and we've talked to other people. One thing that's interesting, I'm not sure, that might be the wrong word, is that a lot of the bad stuff that's happening now was predicted, but it wasn't predicted to happen quite this soon. And so hopefully people aren't going to say, well, the models are not good. I mean, the deniers have tried everything they can from the very beginning to find loopholes or whatever that they can jump on and say, well, scientists don't all agree or whatever it happens to be. And so now we've got a situation where everybody seems to be admitting that we knew it was coming, but not this quickly. And the other thing that seemed to be coming through from some people is that the scientists or the scientific community, because of politics, has tried to be sort of err on the side of things not being as bad as the models might actually show, because again, they don't want to get a bunch of deniers in a spot where they've got another reason to argue against the model. So do you have any ideas as to what's happening, or is it just that things are really actually happening faster than the models thought and faster than anybody essentially understood?
Well, there's a lot to unpack there. First of all, as far as the contrarians' views on these things, those are rarely good faith arguments. And often what's being done is a specific feature of a model or a specific phenomenon within the climate is cherry picked out of a model. And, depending on the way the wind is blowing on any given day, denialists will argue one way or the other, rarely in good faith, about the models being collectively wrong. But as with most things in life and science, the devil's in the details, and it really matters what you're talking about. So just as one example, the models for a long time have underpredicted the rate at which Arctic sea ice has melted. So Arctic sea ice, for instance, has been melting much more quickly than the projections in the models, at least up through the last IPCC report, the AR5. And that's just one example of where the observations that we have are outpacing the predicted speed of the models. Now, the other issue in this is what's right or wrong. That's, of course, it's never a dichotomy either. The models, when we look at the Arctic sea ice projections, the models project an ice-free Arctic and a loss of sea ice that's quite rapid, just not as fast as what the observations have been suggesting over the last decade or more. So it's not to say the models aren't getting it. There just may be differences in the rates at which they estimate them. And each one of these phenomena that either the models agree with observations or don't, takes a lot of diagnoses to understand and see why a model may or may not be getting that behavior. As just one other example, I have a graduate student working on a project right now to try to understand the century-long wetting trend that's been observed in southeastern South America. That's in northern Argentina, southern Brazil. These are really important agricultural regions, tons of soy production, beef production, corn production, et cetera. And since the beginning of the 20th century, there's been a really rapid precipitation increase over that region of over 20% since the beginning of the 20th century. And that's meant agricultural expansion, increases in yields, lots of important things for that area. The models don't reproduce that wetting trend at all. We see models that project drying trends for the region. We see models that project wetting trends, but not nearly as significant a rate, despite the fact that they also project a wetting for this region into the 21st century. And so one of the things that we do as climate scientists is look at these specific features and try to figure out why the models may be underestimating or overestimating the responses. But what's really important there is we're looking at regional features. So when you start drilling down into the models and try to understand how they're behaving on these regional timescales that really matter for humans in policy, but are not associated with the global features that we often talk about or people discuss as, the features of the models. You can find that there are lots of different behaviors that need to be explained and understood from the perspective of impacts assessment. But in terms of the denialist perspective and what's often done with the models is it seems like these individual things will be focused on, and then the expectation is that you can dismiss models out of hand. But the big question about what we should do with regard to climate change and emissions has been answered by the models for a long time. Is there Earth warming? Yes, the models get that. Is it tied to human activities? Absolutely, and it's tied most principally to greenhouse gas emissions, but other things like land use change, aerosols in the atmosphere are important. So, it really depends on the question that you're asking. And I think one of the reasons why the denialists try to make a lot of hay with this is because it is complicated. It takes long answers like I've just given you that aren't easily packaged in sound bites to talk about the models and how they behave. But that basic question of is the Earth warming and what's causing it has been answered and reproduced by the models for a long time.
Yeah, I guess part of what it is for people like me, it's scarier than it was, because based on what's going on now, it looks like we have less time to do something than everybody thought we did last year.
Well, I'll say a couple of things about that. First of all, the uncertainty in the models and the direction that we're going has always been there. But the arguments against the models have almost always assumed that they are overestimating the risks. But the uncertainties are a fan, right? And so there's some sort of mean response. But what people often overlook is that there's a lot of uncertainty in the other direction, which is the risks and the impacts could be larger than what we're predicting as a likely scenario. And so there's all this tail risk that people seem to appreciate only in one direction. But some of the things that we're seeing in the observations now and experiencing around the world, a lot of them are out on this tail risk in the opposite direction. And from a risk assessment, we really need to think about that. Things might be within the model's range of simulations and what we're predicting, but might be way out on one of these ends of tail risks that we've overlooked as maybe too drastic or not plausible, but they certainly are possibilities within the range of assessments that the models are predicting. Not everything. That's not to say that the models aren't capturing or aren't failing to capture some things that we don't anticipate. These, either known unknowns or unknown unknowns that exist. But I think there's this uncertainty discussion that people often overlook, that often when people are emphasizing, hey, it might not be that bad, it might, things might turn out much better, look at here's this end of the uncertainties, they overlook the fact that the uncertainties go both directions.
Okay, because part of it is 2021 is seems like a big year in the sense that a lot of stuff is going on now. I mean, floods, droughts, the hurricanes are stronger, forest fires. All this is going to lead, we've already got some migrations going on. It's almost like we don't need models anymore because we're already in it. And part of it was that the Paris Agreement was trying to keep the mean temperature of the Earth from increasing by more than 1.5 degrees centigrade. And we're somewhere around 1, I think, depends on, I honestly didn't realize, I should have, how sort of messy it was, because they're comparing today's temperatures with pre-industrial temperatures, right, without picking a date. So whoever you are, you get to kind of pick your own.
We're at about 1.2.
Right. So wherever we're at, I think a lot of people thought, well, as long as we don't hit 1.5, not so bad. Then you look out the window and you say, hey, it is pretty bad. And I'm in Wisconsin and affected by forest fires on the West Coast, and we had fires here up on the northern part of Minnesota. There were floods in Detroit, mainly not like in Italy, but they were floods where water was backing up through sewers into fairly wealthy neighborhoods because they couldn't handle the rainfall. So it's like the 1.5 degree goal. Right now, I'm looking at it thinking, well, it doesn't matter if we get there or not, we're already in really big trouble. And I think the UN report was also sort of saying the same thing, that even if we stop using fossil fuels tomorrow, things are already set in motion. That means we're going to keep increasing the temperature. And then I read about people that are going to try and suck the carbon out of the atmosphere, and then other people say, well, it's a good idea, but it won't be enough. So I guess what I'm getting at is you're in the middle of it. You know way more than I do. And I think what people want to know is, should we be more scared than we were last year because all of a sudden the world seems to be on fire? Or should we sort of relax because somebody thinks they're doing something?
Neither. I think we should all be running around with a sense of urgency about this issue. I mean, we should probably all be running around with like our own hairs on fire, really thinking about how we can address the urgency that this problem requires. 2021 has been a devastating year. I think it's been devastating from our perspective because of so much that's happened specifically in the United States. The drought has really accelerated out west, but that's been going on for the last 20 years. We've written papers about, how we're in the midst of a mega drought out there in the Southwest. We've, of course, had devastating hurricanes on the East Coast over the last several decades. I've lived through Sandy and Ida here and multiple others in between in New York City. Spent time in the Boundary Waters up in northern Minnesota, which is burning now. So first of all, it's impacting us in severe ways here in the US. And I think our collective consciousness sort of makes it feel like this year is particularly bad. And it is particularly bad. It's bad globally. The flooding in Europe, the fires in Siberia, we really are starting to feel the extreme effects of a changing climate. And one thing, that's depressing to think about, but I think it's worth the perspective, is this is, in terms of the warming over this century, this isn't just the warmest, one of the warmest years and warmest decades of the last 100 years or more. It's probably going to be one of the coolest decades and coolest years of the 21st century. So just scale all of the impacts as we move forward into this century. And I think that we can expect, this kind of extreme weather and accelerating in terms of its severity and impacts as we continue to move into the 21st century. Now, one of the things that you're mentioning is this 1.5 degree goal. Others have set the 2 degree goal. And that's a really important goal to keep in mind, but there's, I think, important nuances about it. First of all, it was never, if we reach 1.5 degrees C and keep it to that, nothing's going to happen. It was always assumed and projected that 1.5 degrees C or 2 degrees C was still going to create problems for us. And we're seeing that. We're seeing what the climate looks like under, roughly 1 degree and 2/10 of warming. And we're continuing to go in the wrong direction, both in terms of emissions and in terms of warming. But in some senses, they were arbitrary goals in the sense that, 1.7 degrees, 1.8 degrees, 2.1, it didn't mean that if we went over those limits, we were going to fall off a table. They have always been targets to minimize the most extreme risks associated with climate change. So we should think about that in a risk context. It would be great to stay below 1.5 degrees, but if we cross 1.5 degrees, we shouldn't all throw our hands up and say, well, we're doomed. 1.8 is better than 2, is better than 2.2, et cetera. So there's nothing magic in the climate system associated with feedbacks or thresholds that are tied to 1.5 or 2 degrees C. They've always been aspirational targets to limit the most extreme impacts of climate change over those levels. And so I guess, your question about whether or not we should be scared or whether or not we should just give up, I think that's the wrong message, because every 1/10 of a degree counts, every effort counts. And I think one of the challenges of the messaging around these limits is when we do go past them. I think we're going to go past 1.5 degrees for sure. I hope that we stay under 2, and maybe we'll go over and then come back down, and there'll be some path that takes us over for a while. We need to be working like hell to limit the warming and the emissions to whatever we possibly can. And if we cross 1.5, the last thing that we want is people giving up and saying it's too late, because this is a problem that we're going to be facing, throughout the century and beyond. And we need to be pursuing every tool in the toolbox to limit the amount of carbon we dump into the atmosphere. And whether that brings us to 1.5 or 2 or 2.2, whatever, it's going to be better than the business as usual scenarios that put us up over 3 or 4 degrees Celsius by the end of the century.
Okay, is there any chance 2022 will be better? Or are we already in?
Well, it depends on. I can tell you, we study, like I said, we study the Western drought quite extensively. And there are several things that make us think 2022 is not going to be great. First of all, this is a multi-century event, and things like reservoir levels and so on don't recover overnight. So that's going to carry over, and there's some inertia to this. But we can predict with reasonable skill the state of the tropical Pacific a season or more out. And right now, the predictions for the tropical Pacific conditions this winter are for a La Nina. So we would have back-to-back La Ninas, and La Ninas bring drought to the southwestern US. So if those predictions come true, then we will expect a La Nina, and we will expect diminished precipitation in the West, and likely another dry year in the Southwest next year, which would perpetuate the drought at least another year. But I think that's an example of something that we have some predictions for that will carry on. The extreme weather is more difficult, but there are other things like hurricanes that we also know are impacted by the long-term trends. We know hurricanes are stronger over warmer sea surface temperatures. We know that the atmosphere, when it's warmer, holds more moisture, so these storms dump more rain. And we know that sea levels are rising, so storm surges are going to be happening on higher and higher sea levels, which means inundation further and further inland. So a lot of this, we understand the trends. I can't tell you if there's going to be a hurricane next year on, July 25th, but the trends are such that we're going to expect more stronger storms, maybe not more hurricanes next year in the Atlantic Basin and going forward, but the storms we get will be stronger.
Okay, one of the areas that you kind of, sort of focus on is hydroclimate research. And it sounds like that's water everywhere, freshwater, oceans, everything.
Right. Yeah, so hydroclimate has lots of definitions, but when we think about it at the land surface, it's the balance between the water that's coming in through precipitation and the water that we're losing back to the atmosphere through evaporation from the soil and through transpirations from plants.
Okay, because one of the things that comes up, I read about it years ago, is the Gulf Stream that may be affected, but then it sounds like it's also called the Atlantic Meridional circulation. Yeah. How do you pronounce that?
Meridional.
Okay. Some people are worrying about it collapsing. Do you look at that, or?
So, I don't look at it in my research specifically, but I, as a climate scientist, read a lot about it. So there's an important distinction. So, and it gets confused in the popular press a lot. There's the Atlantic Meridional overturning circulation, which is in the ocean. And then there's the Gulf Stream, which is a part of that circulation, but also often applied to the atmospheric circulation or the jet stream. And there's confusion about how much the AMOC, which is the Atlantic the Atlantic feature, the meridional overturning circulation, how much that contributes to the temperate climate in Europe, which actually doesn't contribute much to it. It has more to do with the way that the jet stream is impacted by the Rockies, comes south over the eastern United States, and then comes back up over Europe. And it turns out that you don't influence that significantly if you change the overturning circulation in the ocean. But we do know that this overturning circulation has slowed down, shut off at different times over paleoclimatic timescales. And there is some concern that that might happen and certainly have effects, particularly in the North Atlantic, if it does occur. I think there's a lot of controversy in the scientific literature about whether a slowdown is actually happening, whether you could actually get it under the current conditions. And I'll simply say that there's a lot of debate around it. It's a concern, but in my list of concerns, I wouldn't put it up at the top or even in the top 10. And I think that another reason why we tend to fixate on it, there's a lot of sensational stories that come out when different scientific articles write about it. But I think it's somewhat of the day after tomorrow effect, because everybody watched that movie and thinks that if it shuts down, helicopters are going to fall out of the sky. That's not going to happen. It's great to see climate science popularized through movies and books. I'm all for it. But I think that that's created maybe a bit of a fixation on that particular phenomenon in a way that's not really necessary against all the other things that we have to worry about with climate change.
That sounds good. That's one thing I don't have to worry so much about. I've got a long list too, so I can move that one down. Because of what you do, and because you're obviously following what's going on on the public level, are there things that the media is missing about this whole issue that are just because they may sound too academic and they're not somehow getting into the public sphere?
And that's a complicated question. I think the media's gotten a lot better in their coverage of climate change. 10 years ago, it was just a matter of whether or not they put two talking heads next to each other, one who was a denier and one was some random scientist schmuck who got pulled in because there's lots of us and just a few of them. But it was almost always, some random climate scientist and a handful of, contrarians who were paid by the oil and gas industry to get on and say that it was all bunk. That doesn't happen as much anymore. And, more and more, I think that journalists are contextualizing extreme events. It's still very difficult real time to attribute climate change, to attribute an extreme event to climate change. But more and more journalists are putting, the long-term trends in context when they report on these events like Ida. Let me say this, because in all seriousness, I think that the public doesn't understand what goes into the scholarly and intellectual effort involved in understanding the climate and the results that we generate and try to get out to the public to help them understand what's going on. There's a tremendous amount of effort and brain power and oversight that we all invest in trying to get things as close to accurate and the truth as we'd like them. And that's essential to support. That's an essential public service that you and me and everybody else who pays taxes supports to make happen, because a lot of us are funded through things like the National Science Foundation. And at the end of the day, what we're doing is to try to provide useful and actionable information in light of a threat like climate change. And we're pumping that out. We're writing many publications a year, largely in the service of trying to educate people about the climate system fundamentally, but also the kinds of risks that we're going to face into the future. You and I are paying for that, and it would be incredibly stupid and imprudent to just ignore it all, right? So there's this great quote by Sherwood Rowland. It's basically, what's the use of developing a science well enough to generate predictions if all we're going to do is stand around and wait for it to happen? And I think that's something that we should all be mindful of. This whole endeavor is set up to understand the climate better and anticipate the kinds of risks that we face because of our actions, increasing greenhouse gases in the atmosphere, and what that's going to mean for us and our children into the future. And it's just like COVID or any of these other things that we've faced, there's a lot of effort and knowledge that goes into it, and we would all do well to listen to the expert understanding on what this all entails and take it seriously and actually prepare for the risks that we're going to face and try to mitigate the worst of it by keeping things under a reasonable level of warming.
Sounds good. Thank you very much. Thanks for your time.
Well, it was a pleasure, and good luck with your efforts. We need more of you. Everybody needs to be picking up whatever tool they have to address this.
Great. Thank you again so much.
Thank you.
Take care to you both. Bye-bye.
Okay. Bye now.